Hello everyone. I'm Wallace Kelly. I'll be delivering this webinar beginning in just a few moments, Introduction to F#. And I'm just going to do a quick check here to make sure everything looks okay and sounds okay. All right, I have the green light to proceed. First, I want to say thank you for all those who are attending right now. I appreciate you signing in, and this is going to be recorded, so thank you to all those who are watching it later, sometime in the future. Also, thank you to Develop Mentor, who is sponsoring this, put this together, and Learning Line. Develop Mentor does instructor-led, in-classroom training, and their Learning Line product I've been involved in, and that's our online training product. The title of this talk is Introduction to F#, the what, why, and how to get started. And so please consider Develop Mentor next time you need in-classroom training, and go ahead and sign up at learninglineapp.com for a free trial of our online training product. I'm assuming that most of the audience here is already .NET developers. That's where I came from as a .NET developer. And so I'll be using some examples, doing some comparisons with C#, and assuming that you already know about the IL that you would see in an assembly. But if you're not already a .NET developer, hopefully you'll still get some out of it. But yes, that is my assumption about the audience. Let me tell you a little bit about myself. You can connect with me on Google Plus at google.com/Wallace Kelly PhD. I earned a PhD from Texas A&M. I am a .NET developer, and while I wear many hats professionally, one of those hats that I wear is as an instructor. I really enjoy taking people from what they know to what they would like to know, and that's why I teach for Develop Mentor, and I've actually developed a good deal of the content on Learning Line. So the best way for you to stay in touch with me and to get access to some of the free videos that I send out occasionally on YouTube, the best place to connect is adding me to one of your circles on Google+. As I mentioned, I'm a .NET developer. Most of my work recently has been in WPF, been writing WPF clients that access web services. I also build the web services. I access databases. Been doing some work with CUDA, which is doing a lot of computations in a GPU in order to improve your ability to do some high-performance computing. Most of my development is in the area of scientific and engineering software, although it is somewhat varied. For the last year, I've been working almost exclusively in F#, and that's pretty much what I'm going to be sharing with you is my experiences, the things that I've learned, and I want to really motivate you to become a developer of using F#. So what I'd like to do is, that's an introduction of myself, and I'd like to get an introduction from you. So if you'll look at your GoToWebinar client, you should see a poll come up in a second, and I'll share the results with everyone as well. So tell me, as the presenter, tell me a little bit about yourself. Are you not a .NET developer? Maybe you're working in something else. Maybe you're working in Python or just C or Java even. And maybe you're a VB.NET developer. Maybe you've already started in F# and you're just curious to see what an introduction would look like. And maybe there's some other kind of .NET developer that I didn't think of, Iron Python or something like that. So the poll's in progress. We've had 80% voted. Anyone else before we close the poll? Give you a couple more seconds to make your selection. All right, so we're going to close. It looks like 82% are C# developers, so just as I might expect. For the 8% that are not .NET developers, oh, here, I can share these results, I believe. All right, so yes, attendees are viewing the poll results. So we got 8% that are not .NET developers, welcome, and a few VB.NET developers thrown in, and another kind of .NET developer. Not sure what that would be. All right, well, thank you for telling me a little bit about yourself. Let's go ahead and continue. I'll need to hide the results. Okay, so here's the outline that we're going to be using. First, I'll talk about what is F#. And today's presentation, as I mentioned, is going to draw on experiences of someone who is already making that transition. So I'm going to be telling you about my experiences, the things that I've learned. I put together some observations from the last year, just try to make notes of what I would like to tell somebody that is interested in or just getting started with F#. First thing you need to know is what is F#. I'll show you that it's a .NET language. It compiles down into IL just like any other .NET language. However, what makes it different than the other .NET languages is that it's a functional first. It's multi-paradigm, but it assumes a functional style of coding. Second thing that we'll look at is why should I learn F#? Why should you learn F#? And I'm going to give you several reasons. One, it represents a new style of programming, and you want to keep your skills on the cutting edge. You don't want to get left behind. You don't want your skills to become antiquated. And F# represents a evolution that's taking place in software development, and so you want to stay current. There are other functional languages that you can learn, but the advantage, why you should learn F# as your functional language, is that it runs on top of the .NET platform. And so you get all the benefits of what some of you already know about the .NET platform, but if you don't, there's just a huge amount of functionality available in the .NET platform that you can take advantage of and that you can deploy to real customers or real clients. You will become, another reason why you should learn F# is you'll become a better C# developer or VB.NET as you go through F# and learn these concepts. And we'll also mention that it will likely, if you're like me, the reason you should learn F# is because it's going to become your preferred language. It's going to become the language that you're going to want to use. Lastly, we'll look at how to get started. I'll walk you through the basic tools for compiling F#, how to set up a library, an F# library that is callable from C#. And then one thing that you might not see in other introductions to F# that you will see here is that I will share with you some of the less than favorable aspects about making the transition to F#. Most of that is related to tool support. And you should keep in mind that if you're watching this recording, right now it's March 2014, and so by the time you watch it, maybe some of these challenges that I'll be mentioning will go away as tool support improves. But I do want to let you know what you're in for. Also keep in mind that we only have an hour, so the goal isn't to get you started developing F#. The goal is to get you motivated and to help to remove some of those initial barriers that I felt when I first started. That's our outline. But the main point that I want to emphasize, the main thing that I want you to take away is that when you learn F#, it's going to give you a wider range of tools. You know, my dad taught me how to build things with wood, how to construct, do carpentry. He also taught me how to work on cars, and one of the things he always told me was that if a job is difficult, if you're finding it difficult to accomplish some task, you're probably using the wrong tools. And so you can probably accomplish a lot with this toolbox that's on the left. However, if you learn to use the tools that are here on the right, you'll be able to do the job more quickly, and the end product will be of much higher quality. And so that's the analogy that I'd like for you to keep in mind as we're going through and learning F#. You should think of F# as a new set of tools. Some of them are identical. You can see a hammer here on the left, and there's a hammer somewhere in this toolbox on the right. So some of the things are applied directly from F# and whatever other language you're using. But some of the things that you're going to learn with F# are more specialized or even more flexible than your current tools. Yes, can you build some of the same stuff with any .NET language as you could with F#? Sure. But my motivation here in this webinar is to show you that F#, and especially, I'm going to be focusing especially here on the language level, you'll have a lot more powerful tools available to you if you do learn them. But again, I must make two concessions about this analogy. There's a steep learning curve with F#, and we'll get into this more, but if you know how to use these tools here on the left, there's some of the tools over here on the right that you really need to spend some time understanding how they work. And so yes, I personally have experienced a steep learning curve making the transition. And again, the language is very powerful, and that's going to be my focus, but I have to admit that the editor and the designer support is currently lacking. And I'll show you some examples of that. So just to summarize up, transitioning to F# will likely take a good bit of work. Your experience may be different. Maybe you have a background where you're going to be able to make that transition very easily. For me, it had been a long time since I had learned a new language. In fact, it was from when I went from Java to C#. And that was an easy transition to make. There's really not a lot to learn there. And that is not how it works with going from something like C# into F#. There's a different syntax. There's different contexts. But finally, I would just want to say it's all worth it. It's been definitely worth it for me to make that transition. In fact, when I go now and I have to work on some older C# code, there's two things that I notice. Two things that I notice when I'm having to work on some older C# code is that my hands instinctively feel tired. Just thinking about it makes my hands feel tired because I know I'm going to be doing a lot more typing than I become accustomed to in F#. And the other thing is my mind starts to get bored because I'm having to do this extra typing. I'm having to do things the same old, long, drawn-out way that I would do in another more imperative or object-oriented language. And so the F# keeps my mind much more engaged and makes it much more interesting. I have a couple of questions here. I'll try to address these as we go through, but we'll see. I want to know how to think functional, not from object-oriented. That's exactly right. And so when you jump into F#, that's what you're going to have to start doing, is start thinking about the code differently. And that's part of that learning curve. So yes, I agree with that comment that you want to start thinking functionally, not object-oriented. Is this webinar going to continue at such a sluggish speed? Speed things up. All right. Thank you for the feedback. Let's go. What is F#? F# is a .NET language. So first, F# is a .NET language. It's been included in Visual Studio 2010. And later, since, it's been in there since 2010. The compilers are available for Mono. It compiles into IL, just like any other .NET language. And because it is a .NET language, you also have access to the .NET framework. You can easily access code or assemblies that you build with F#. You can easily access them from other .NET languages. So let's do our first demo here. And I'll show you from scratch how this might work, how you might write your first F# hello world. So I'll create a new file, hello.fs. And what I want to do is put hello world on the console. If this were F#, I would expect to be able to do something like console.writeLine and say hello world. In F#, you don't use using for system, you use open, but it's the same basic concept. And so you can see here that I'm accessing a class from the framework and calling a method in much the same way that I would call a method in C#. One difference is you'll see that there are no semicolons. To compile it, I could simply use the F# compiler, hello.fs, and then I can see that I now have an exe for hello.exe, and that runs just like any other assembly. So yes, it is a .NET. F# is a .NET language. If we wanted to, I'm going to recommend to you later that you get this cool tool called ILSpy, and ILSpy is a lot like .NET Reflector that will open up .NET Assembly and show you what's inside. And so that's instructive. So you open up hello.exe. I can expand out and find where did my code end up. And eventually I get down here to an auto-generated main. And so there's my code inside this main that was auto-generated. Notice I didn't have to include any kind of main. You can define entry points in your F# code, but certainly you don't have to. They automatically get moved into a main if you don't define an entry point. Okay, so that's our hello world. The second thing that the slide said is that F# is a functional first language. And what we mean by that, let me show that on the screen. F# is a functional first language. And what we mean by that is that the F# syntax favors a functional style of coding. You can still write object-oriented code. You can still write the imperative style of code. But the syntax is designed around the functional style of coding. So I'd like to give you an example. So one of the concepts of functional coding, one of the concepts of the functional style is to prefer immutable types, to prefer data structures that cannot be changed after they're created. And so because F# is functional first, it will assume that your symbols are immutable. In other words, by default, the symbols that you define are not values, but they're actually variables. So let me show you an example of that. I did just a moment ago, I did hello.fs. Another extension that you can use is FSX, and that is for F# scripts. So let me open that, FSX, and I'll open it up in Visual Studio. With these FSX files, you don't have to have any kind of project. You can just use Visual Studio as an editor. And here is a script, an F# script. Once again, open system. Here, as I just mentioned, I'm defining not a variable, but a value. Label MSG for message, and then its value, do you like my hat? If any of you have young children, you'll recognize the theme here. Printfn is similar to the console.writeLine. The difference is that it's type aware, so it's expecting a string here. Then you'll see that I try to change the value of message to yes, I do like your hat, and then try to print that out. Let's see how this runs. So how do I run the scripts? The way that you run the script is with FSI, the interpreter. And again, you can compile to EXEs or DLLs, but sometimes this is convenient. So I'll do FSI hello.fsx, and you'll see here that what happened is that it printed do you like my hat twice. Even though I have message equals yes, I do. And so this drives home the point that types are immutable. And in fact, this is the wrong syntax for what I intended. What I intended is for message to be assigned a new value. But what's actually happening here is that this is a comparison operator. So if I were to do this, is different. That's what's really going on there, is that message, the value in message is being compared to that string, right? So equals is not the correct operator here. The operator that I want in F# is the assignment operator, which looks like this, for changing the value of the message. What I would think was a variable, but in fact it's not. And in fact, that red underline tells us that, in fact, this value is not mutable. So that's what we mean by it's a functional first language. The syntax by default assumes immutability. For example, if you wanted this to be a variable and not a value, then I can add a modifier here to make it mutable. And then sure enough, now it's a mutable string, and I can assign its value, run it again, and it should run just fine. Yes, I do like your hat. Notice that some of the syntax for F# can be succinct. Here there's no, as I already mentioned, no semicolon, but also no parentheses either. So that decreases the number of characters in your code and the amount that you have to type. We do use parentheses for tuples, which we'll get to in a moment. Okay. One thing that might come in handy when you're learning F# is to change the association of your FSX files. So by default, I think if you install Visual Studio, if you double click on an FSX file or run it, it'll open it up in editing mode. But you can change it and have it open, choose the default, and have it open in fsi.exe. And the advantage is that now if you have a F# script file, you can just double click on it and it'll run. And so that's kind of convenient. It is being interpreted, or compiled rather, at runtime, but that can make your scripts executable simply by double clicking. I'm going to change that back because it's convenient for me to be able to edit them. Oops, I need to set the default. Open with, choose default, and then Visual Studio. Okay. The F# is a functional first language, and so let me take this a step further. What we have here is very imperative. Do this, then do this, then do this, then do this. To make this really look like F# code, the way that it would probably be written is for our messages to be put together into a list. We like to treat in F#, we like to treat our data as an integral part of the logic of our code. And so here is how we define a list in F#. This list has two items in it, two strings. And I could even assign it, let messages equals this. In my case, that would work just fine. I would need to separate out I would need to get the indents correct. That's the other thing. Since we don't have semicolons and we're not using curly braces, the indentation is what sets your code apart and clarifies where your statements begin and end. So if I were to do this in F sharp, write this in an F sharp way, it would probably look something more like this, like so. And so this would accomplish exactly the same thing. It says, take this list and iterate over that list, calling this function. And in this case, it's a function that's been curried, meaning that it's a function that takes more than one parameter, but we're going to take the items from this list and feed it in as the last item in this parameter. So I can once again run this like so. And we should get the same result. Okay, I see that I have a question. Lots of questions here. Is let an assignment operator like equals? Okay, let is an assignment operator. So when you use equal with a let statement, it is indeed an assignment operator. So yes, equal here in conjunction with let is an assignment. LINQPad has support for F sharp. I think that's a statement, and I think you're correct, but I don't remember for sure. I do have LINQPad, but I don't remember if it has support for F sharp. What other functional-based languages are there? Put another way, what languages is F sharp similar to? So there are other functional languages are Haskell, OCaml, and if you're from the Java world, the equivalent for F sharp would be Scala. Okay, great question. Thank you. Let's continue. That completes what is F sharp, a .NET language, and a functional first language. So now let's move on. The second item, why learn F sharp? Why should I learn? If you're already programming on the .NET platform, you can already write server-side apps, you can already write web applications, you can already write desktop clients. Why should you learn F sharp? This is my personal opinion from my personal experience. So I'm going to give you the reasons why I'm glad that I learned F sharp. First, you really want to stay on the cutting edge. If you think about the evolution of our craft, you can think back to the early days when people were writing assembly code, and then we got some nice compilers for C or COBOL or Fortran that allowed you to write a little higher level procedural code. Then when after that, the next major step in the evolution of our craft is object-oriented, and so we had compilers for C++ and Objective-C. And then keep staying with me. We followed that with managed execution, so that a lot of the developers moved, not all, but a lot of developers moved to .NET and to Java, or to Java first and then .NET. And now I would suggest that a similar thing is taking place, that the next evolution is towards functional programming. And so that would be F sharp on the .NET platform or Scala on the JVM. So why should you learn F sharp over any of those other languages? Well, because it is a .NET language, especially if you're already a .NET programmer. You can do F sharp on the .NET platform, so that works really well. Another reason why you should learn F sharp is just to become a better programmer. Even if you're not going to be able to do F sharp in your day job, even if you're going to be continuing to use VB.NET or C sharp, if you learn F sharp in your spare time and on your pet projects, you're going to become a better developer even for your preferred language or the language that you're going to be using on most of your projects. You'll begin to see the advantages of the functional style and start using them in C sharp code. You're going to start trying to write immutable data structures in C sharp and see that, wow, this takes a lot of typing. If I were doing this in F sharp, this would just be a few lines of code, a real quick declaration. And so you'll start using more functions, small functions, and inside a function, defining small functions. And you can do some of that in C sharp with lambdas. And even the evolution of C sharp is similar to the evolution that the craft is taking towards more functional style. But instead of having explicitly defined actions of T's or funcs of T's and T's results, you can more quickly define short little functions that do some specific functionality. And so it'll make you a better C sharp programmer, but eventually, if your experience is like mine, F sharp will become your preferred language. Some people think of F sharp as being just for mathematics, just for science, just for engineering, just for finance. And I would suggest that that's not true. If you want to do object-oriented code, I much prefer writing my object-oriented code in F# now, and even doing my WPF client. I do my WPF clients now completely in F# without any C# code. So there's a certain level of conciseness there, and then there's the support for the functional style. Lastly, why should you should just have more tools in your tool chest. And so I'd like to spend some time talking about what some of those tools are. So allow me to show you some examples of the new language tools. Let's look at my first one that we're going to look at. The first one is going to be match expressions. Let's do this in Visual Studio. Do I have a patterns? Yep, I have a patterns.fsx. These scripts are really convenient for learning, for doing demos, for doing little utilities, and that's why I'm using them. But again, most of the time I use real Visual Studio projects. So here we have an expression. It's an expression to match. So here's the expression match, and it's defining a function. It's defining a function called nameConstant that passes in some value, and then it compares that value with these literals here. So if x matches 2.71, then our function is going to return e. If the passed in x matches 3.41, it'll return in pi, and so forth. So what I can do is define this function, which is simply that match expression, and one way to do that, a convenient way to incrementally code or to experiment, is using the FSI interactive. It's a window that you can make visible here on other windows. Where is it? F# interactive. And it's similar to the immediate window that you may have used, but the difference is that it's not something that you would use while your application is running or during debugging, as in breaking in and modifying the state of your running application. This has its own environment that you can set up. So I can define in this environment, I can define this function. So now I have a function down here called nameConstant, and I can call that function by passing in some kind of a value like so. And so this F# interactive window gives me the ability to incrementally work on my code and try things out, see how that would work. Comparing this, how we might do this in another language, you might think of it as a case statement. It is very similar to a case. Switch on X, and then we have our cases here, but it's much more powerful than a case, and in fact it's more like a series of if-else statements. Here's something that you can't do with switch case in C#, for example, is test to see what is this type that's being passed in. So I'd like to describe some kind of object, and again, X is my variable, my value really, and I'm going to be passing it in passing in some kind of an object, and I want to see what is that object. So now I have a describe function, and I can describe 3.14 like so, and it's a float, and I can describe a string like so, and I don't have that case worked out. So match is better than a switch case because there's a lot more flexibility. In fact, you can do things like this. We can match this x and y that is being passed in and have some arbitrary when clause. So this is referred to as a when guard. And so it's just a test that takes place. And so really what this match becomes is a chain of if-else statements, except that it's very succinct. There's a lot less code here. And there's many other possibilities. I've shown you 3 different pattern matching expressions that are used with match, but there are several, there's dozens I would suggest, and you can even create your own using active patterns, create your own conditions here or cases for your match statements. Okay, so that's the first. It's a relatively small tool, but it's a representative of what you're going to see overall. You'll see that when you have these additional tools of like a match expression, your code is going to be much more succinct, much less to look at. Here's that same code in C#. In fact, I got this code from ILSpy by decompiling the F# generated code. Here's another example. type extensions where we have new language tools. So in C#, you're probably familiar with extension methods, where you can add a method like isCapitalized to the string class, and that makes this isCapitalized method appear as if it's on the string class. Well, with F#, you can certainly do that, but you have even a more powerful tool of being able to do type extensions. So here we have a type extensions for the string class, and instead of adding a method or making it appear as if we have a new method on string, we're actually defining a new property, something that you cannot do in C#. So let me just try that real quick. Let's demonstrate that. So that would be which one? Type extensions. So here's this. I will send this to F# interactive. First I'll clear it out, reset it. I select it all, and then I think for my editor, Alt-Enter will send it here. So now we have type string with this additional property. And so I can put in Wally.isCapitalized and true, like so, and false. So we're able to extend this type with different kinds of members, not just methods. Again, not a deal maker at all, but it is consistent with what you're going to find in your own experience over and over again. Query expressions. So I would hope that many of you are already using C# LINQ, and so you're familiar with writing code similar to what's over here, or in LINQ, language integrated queries. In F# you have that same tool, but it's a lot more flexible. There's a lot more that you can do with it. And so I'd like to do that demonstration to show you how we might do that. So I have a little example set up. Let's see. Families, queries, and I have a project already stubbed out. Okay, so here is, I've defined a type person. This is referred to as a record. I'll get more into that later, but it has 3 members, and you can see there we have a property and a type for it. I've defined a list of family, and these are my wife and my children. You might notice that I'm in there twice, and that's important. And so now what I'd like to do is get a list of the parents, like so. And in F#, what you do is you define a query expression. You use the word query and then start writing your query expression inside here. In other languages, you might say from. Here we do for we'll say person in family. And I want to do where person dot, let's say age is greater than 18, like so. And so this should look somewhat familiar to you. I want to select my person, like so. And oh, yes, one thing here, and if those who already have F# experience will know what I did wrong. In F# there is an extra do here because we don't have the that's just the way that they do for loops in F# because we don't have the curly braces to delimit where our loop begins and ends. So we have a do statement here. And so let me run that. So I'm going to define this in F# interactive and define my list. And so it's copying it down there. In fact, I'll just move it over here so it'll be perhaps a little easier to see. And now we have parents. And let's take the parents, and I want to printf like so, parents. I want to get I want to print out information about the parents. The %a just says show me information, and so here we have our list of Wally. Wally's in there twice. Terry is over age 18, and so is Andrew. So I still need to do a little bit more work on my query. Let me do this. I'm going to do for person in parents, do this, printf in, let's do A, and then P. Let's see, did I get that right? Yep. So if I execute that, and so, well, let's do the names just to make it clear, like so. All right, so we got 2 Wallys, Terry, and an Andrew. And what I really want is just the parents. I just want Wally and Terry. So let's sort sort by descending. That is a F# operator in a query expression. And then we select it. And I need to do P here. So I'll execute all of this again, in fact. And, whoops, nope, just do this one. There we go. Well, sorting didn't make any difference, but now I want to do distinct. And if you'll remember if you're already doing LINQ in something like C# or VB.NET, you'll know that distinct is an extension method that you have to tack on to the end of your query. Well, in F#, distinct is one of the options for a operator inside the query. Like so. So now I've eliminated that extra wally, and now I want to only take 2. And the same thing, there's also a take operator in F# that allows us to include that directly in the query. So now I've brought it down to just the 2 adults. Again, just another small example how the F# language itself has improved tools. I use the example of distinct and take 2 rather than the extension methods, but you'll see that there's a whole host of these. Here are all the query operators. We got count, last, exactly one, head or default, select, where, min, max. All those are available as query operators directly in the query expression. Same thing with async workflows. In C# and VB.NET, you have async and await. And in F# you can do that same thing. It's implemented a little differently with F# async workflows, but it's a lot more flexible. There's a lot more that you can do with async and await than just async and await. Here the example that I have is start immediate, and what that means, start immediate, means that we would like to execute this asynchronous computation, this asynchronous expression here. We'd like to execute it, but we'd like to start it using the current thread. And so then the current thread goes in and starts executing this code, which in this example, we're not going to do it right now. I'm looking at the clock. In this example, we're not, it would go out and get a web page, and then the use bang means do the rest of this asynchronously. And so then the calling thread would exit, and a worker thread would go off and get the result, and then continue on from there. And so we have more than just async and await. We have do bang, use bang, let bang. Async itself has a large number of methods on there that allow us to even do more complex, asynchronous workflows. I'm going to go ahead and do this demo. Type providers is an amazing tool. Maybe you've already seen an example of this. If not, you're going to be amazed at this. So I'm going to jump in here and do a type provider example as another tool that's available to you when you make this transition to F#. Let's see. Which one is it? Type extensions. Nope. Let me find it real quick. Type providers. I guess I didn't make one, so we're gonna go from scratch here. Type providers.fsx. Oops, I don't want that. I want it in Visual Studio, like so. So I have a F# script, and in my F# script, I want to use code from another assembly. And so the way that I do that is with the #R, and I want F#.data. Is it .dll? And so this is the equivalent if I weren't using a script, if I were using a project, this would be the equivalent of adding a reference to that DLL. Then what I want to do is I'll add the equivalent of a using statement. I'll do F#.data, saying that I'm going to be using types from that namespace. And then what I'd like to do is I would like to have a type that can read in this sample.json. So here is some JSON data. It's an actual response from Twitter, and that I retrieved from an example site of Twitter feeds. And I've saved it into a text file. And what I'd like to do is read this in and have a type where the properties of the type match the entries here, the key value pairs that are in the JSON data. All right? And so what I can do using type providers allows me to open up Twitter. I want a new type that can read this Twitter feed, and I'm going to use the JSON provider, like so, sample.json. And so what this does is the JSON provider at design time, meaning as I completed typing this, as I finished typing this, that JSON provider ran in the background and it auto-generated a type that can read data similar to what's in my sample. And in fact, I can create an instance of, or I can load in rather. So we'll do Twitter JSON dot. We'll load, and I'll just simply load the sample.json, like so. And now if I look here on my value TW, you can see that there are all these properties that map to what we saw in that sample JSON. In fact, here you'll see that there's a max ID, for example, a max ID key in the JSON data. And so that corresponds to a max ID property. Again, this is a script file. There's no other project. There's no other code running except what is exactly here. That is really powerful. And just last week, I wrote my own provider. So this is extensible. You can write your own providers. Mine was a provider that would open up MATLAB file and get data, get the schema using the information in the MATLAB file, use the schema of that to create types for reading and working with those MATLAB files. So it's an extremely powerful capability and one of the new tools that will be available to you in F#. How would you refresh your type then, assuming you want to update your JSON file? That's a good question. So the question is, if sample.json changes, what happens? So let's do a quick test here. I already have it open, and so we'll make this max identifier like so, and we'll save it. And let's see what it's going to take to get that to come up. Look at that. It's already changed. Okay, so we have max identifier there. Thank you for that good question. Okay, so we're going through a list of tools, and this is probably the most powerful tool right now, is the ability to define type providers that at design time will give you strongly typed objects that are able to work with your data. All right, so that is my summary. We could go on. I could continue with more examples of the powerful language and the powerful tools that come with F#. And so I hope at this point that you're convinced, if you weren't already, it's worth your time to learn F#. But I am curious about your opinions and about your feedback. I see there's another question. I'll get to that in a moment. But while we are waiting, let's take another poll. So I'm going to turn on, which one of these do you think is most interesting to you? Why should you learn F#? So I have 5 options there. You want to, as I said, you want to make sure you don't get left behind. You want to learn a functional style of programming, or maybe you want to become a better C# or VB.NET developer, or maybe you're interested in the more powerful features. I'm glad to see that there are some people who you have an upcoming project, and it's part of a requirement to do that. So a lot of good responses here. I'll show those in just a moment. And while those responses are coming in, let's look at what the question was. Question: is the type created on the fly? So yes, with the type provider, the type is created on the fly. And there's 2 ways of creating those types. One way is referred to as a generative type provider, where that type is created on the fly, actually compiled into an assembly, and then referenced by your script or your project. The other way is an erasive type provider, where it's all done in memory, it's all done in reflection, all done in just providing type information at design time. How much does the hybrid nature of F# get into the way of functional learning curve? Great question. How much does the hybrid nature of F# get into the way of the functional learning curve? I would say that that's a big part of it. There's a lot of value in being able to interoperate with the other .NET languages, but you're right, there's always kind of two worlds there. You're having to do the functional style and you want to prefer that, but then in the end you need to be able to interoperate and you need to be able to create classes. I would love to not have to create any more classes, but in a WPF client, everything has to be a class because the WPF is working with those classes. I should clarify, and an astute listener would have already corrected me, is that even when I am when I'm writing this code, I am actually declaring class, or the F# compiler is putting them into classes. In F#, you can define classes, you can define records. They all end up as classes in the .NET assembly, but as far as the language is concerned, they're different. Question, how is strongly typing fit with .NET then? Everything in F# is strongly typed. It is not dynamically typed. It is not weakly typed. It is strongly typed. You may have noticed that when I was typing code, I did not have to specify what the types were. The F# compiler is inferring those, and they are determined at compile time. So F# is strongly typed. Required for upcoming project for me meant that I'd only learn it if there was an upcoming project. Oh, good. Thank you for clarifying that. Let's get back to the poll results. Another question. So is the type going to change when the file metadata changes on the fly? I assume that you're talking about the type provider. Yes. So the type provider, well, it's fixed at compile time. But if I changed in my sample JSON, for example, if I changed it from a number to a string or so forth, at compile time, it would appropriately be a string or a number. Let's see. Let me show you your results. Thank you for participating in the poll. And I'm going to close the poll and share the results so you can see what other people are saying. Looks like the winner was stay on the cutting edge, followed by interested in more powerful tools, features, and becoming a better developer overall, and maybe some other reasons. And Neil clarified that it was if he had a project coming up, then he would be interested in learning F#. Okay, getting started. I have a little bit more to show you. I see that we're coming up at the end of the hour. So getting started would be you need an IDE. On Windows, probably just use Visual Studio, especially now since Visual Studio Express 2013 can support Visual F#. It is a separate install. If you had a paid version of Visual Studio, it'll already be there. If you're on Mac or Linux or want to compile towards iPhone or iOS rather, or towards Android, then Xamarin Studio may be of interest. Either way, you'll want to get ilspy.net. That was a huge help for me. Write my F# code as I see in examples, but I want to know what is that actually going to look like in the IL. Let me go through what you need to know to get started. Or in other words, this is the stuff that I wish someone had explained to me when I was first getting started. So these are things that I had to scratch my head for a while to really understand. So this isn't necessarily a systematic approach. If we do some in-classroom training, we'll go through systematically, but I just want to give some of the lessons that I learned that were hard for me to learn initially. And to do that, I'm going to use an example here in Visual Studio, and this is actually a project, and the project is this one here. It includes both a F# project and a C# project. So we're going to write some code in F# and then call it from C#. Here's my F# code, a single F# file. Module, developmenter, demos. You can see it says module and then has all this stuff. And maybe I would like to write some code here. So the first thing that you need to recognize, the first thing that I wish somebody explained to me was really explained well about modules and namespaces, because that had me confused for a little bit. So let me explain it to you well so you won't stumble on that. And to explain it, let's do a simple thing here. Number of months in, let's do this. Months in year equals 12. All right, so we can't get any more simple than that. I'm going to compile that, and I'm going to open it in ilspy so we can see what this module compiles as. Demos, monthly payments, going into the lib, which is the F# project, and then monthlypayments.lib. expand this out to monthly payments lib. So you may remember that in my code at the top I had module developmentor.demos.monthlypaymentslib. And so a module in F# compiles down to simply a static class in the IL. That's all there is to it. That's pretty simple, right? And the difference between when you define a module, anything before the last dot becomes the namespace. And so I could also do this. I could say that this is a namespace. And then my module now will become separate. I'm going to say a module like so. And then indent everything under here as part of that module. Wow, in just 1 minute I've saved you some grief. Recompile it and you'll see that it's exactly the same thing. Refresh and we get exactly the same result. Okay, so modules are static classes, and this, I didn't point it out. Let's look at months in year. How did that get compiled? That was compiled into a property. Okay. And you can so namespaces and modules are different, but they interact in the way that you define them. Recognize value and functions. All right, so we have comments and questions. Let me make sure this isn't an emergency. Open the questions. Can you show the screen again? I only see the quick poll. All right, thank you very much. I should have checked earlier. I left the poll running. Hide the poll. And now we're back to my screen. The only thing that I think you missed, yeah. Thank you. Let me see if there's any. That's probably what people were raising their hand and trying to get my attention. Now I see it. Thanks. Yes, you're welcome. My apologies. Visual Studio Xamarin, I recommend ILSpy. What do you need to know? Modules and namespaces. Oh, and you didn't see my demo either. So let's show my demo. What a shame. Namespace, developmentor.demos. Here's a module. Has a single member. If we look in ILSpy, that module was compiled into a static class. So now you can see what I was discussing, what I was talking about. Okay. The other way that I showed this while you were staring at the poll results was that instead of having a namespace at the top and then the module defined separately, you can put the module definition here like so. And that would be, oops, and I take off the equal. And that would be equivalent. So here I'm saying the module, this last thing is the only module. Everything else is just namespace. Okay. And so that's the point of that is it's helpful to understand modules and namespaces. It's also helpful when you first get started to immediately recognize when you look at it, a value versus a function. Let me try to clear out my questions here, make sure that I didn't miss anything. Yep. And okay. So let me clarify that. This is a value. It's being auto-identified, it's being type inferred as an integer because I've set the value to 12. Let me give you an example of a function. So calc months remaining. If I do this, date time is in the system namespace. Today.month. This is a value. I name it calc, and I'm doing some calculation here, but it's only going to be calculated once, and that is going to be the value of this symbol. If I add something additional here, and it may just be as simple as an empty set of parentheses, now this is a function. And that's what makes this a function. And anytime I call calc months remaining, this code will be run. I might also have a function that does something like calculating monthly payments. I've already written this one out so that I wouldn't have to type it for you. Calculate monthly payments for a loan. And here's my code. And as inputs to this code, I need to know the years. And so here I'm going to put anything after the first symbol of the let. Anything after that becomes a parameter to that function, like so. And so now this is a function. Calc monthly payments is a function that takes, the way we think of it is it takes three parameters: principal, annual rate, and years. Now notice that these are being, the type inference is automatically, we're already automatically getting the type inference. These are floats. And the reason that the F# compiler is determining these to be floats is because of how they're used. Here, annual rate, it's being divided by a float. And so therefore, annual rate becomes a float. Years, it's an integer, simply because, in this case, the F# compiler, integer is the default. I'm having to cast it to float in order to multiply it by 12. Okay. So now I can compile those and even have access to those, to that code over here in C#. I already have a reference to my F# project, monthly payments lib. And so I know that in there is a monthly payments lib static class. It's in the developmentor.demos namespace. And calculate monthly payments. And you can see it takes a double, which in F# speak, a double is a float. Yeah, that's a difference. Float is a double precision. So principal, annual rate, and integer years. Okay. So recognize the values, the difference between values and functions. They both use let. The difference is that after that first name, anything after that is a parameter. Understand the functional type descriptions. This is going to be important. Let me just put in some numbers here so that it'll compile. 30 years, like so. When I mouse over this, what comes up is non-intuitive to me as a C# developer. But what this says is that the name of this function is calc monthly payments, and it takes a float, it takes a double precision, a float, takes a principal, and then it also takes an annual rate, and then it also takes a year, and then it returns a float. My point is that when you first get started with F#, it's worth digging into and understanding this syntax here. The idea with these functions is that any function only takes one parameter, but it might return a function that takes another parameter. And that's what's going on here. Calc monthly payments takes a parameter of a principal. That returns a function that takes a parameter of an annual rate, and so forth. And when you do something like this, which you might expect when you're defining a method, when you do something like this, you're changing the definition of this function. This function now no longer takes three parameters. It takes a single tuple with three members. And if I mouse over it, it's going to look different. You see, now calc monthly payments, that asterisk there identifies it as a tuple, and that arrow at the end says what it's going to return. So it takes a single tuple with four members, and we define tuples with the parentheses and the commas, a single one, and then it returns. The advantage of defining them like so is for the purpose of function currying, which I'm not going to get into for lack of time. I was planning to get into it, but I see our time is just about up. So we'll leave that for some other webinar. Next thing to know is use records. They're immutable classes. You can think in F#, you can think of records as a class. It's immutable, so it's different, but that's what you would basically use. Now for the bad. You've seen the good. Now for the good. Now for the bad and the ugly. So I'm going to end here with the fact that the F# has a huge learning curve. That for me personally, it was a lot to learn. the editor lacks features. If you use F2 for renaming, if you use F12 to go to definition, that will work, but only if your code is in F#. It won't go to C#, for example. There's, what else do I have here? No find all references. When you do an override, it's not going to implement the virtual base. It's not going to stub out the virtual base class methods for you. So there's a lot of features that are not yet in the editor. And there's no designer support for code behind. So if you're used to ASP.NET Web Forms or WinForms, where you have a designer and you double click on something and you go to the code behind, none of that is there for F#. All right, I see that I have exhausted my time. Let me see if there's any comments. You can go as long as needed. Great. Mary has just given me permission to go longer. Thank you, Mary. Yes, so I won't rush then. Let me, I did cover that, but so let me just show you that real quickly then. If I right click or if I look at edit, when you're using VB.NET or C#, there's a refactor down here. That's missing. Let's see. That's the one that I miss quite often, the refactoring things. Well, so we'll leave it at that. I've lost my groove, so we'll continue. Last slide. What to do next? So I have 5 specific recommendations for you. 5 specific recommendations, and I hope you'll go through them in order. One is to connect with me on Google+. My favorite way to share stuff is with videos, and so I create videos on YouTube and share them through Google+. You can find me on Google+, or just go to tinyurl.com F#intro 1. Then after that, go to tinyurl.com F#intro 2 and watch this awesome talk by Phil Trelford. I think the name of his talk is F# for the C# developer, F#I for the C# guy, something like that, something clever. I can highly recommend this website, F# for Fun and Profit, and again, a tiny URL there for F# Intro 3. This is the book that I use by Chris Smith, F# Intro 4 on tinyurl, Programming F# 3.0. I can recommend that. There's other good ones out there, and if you're watching this as a recording, there may be some better ones. And then lastly, go to Developmentor, and for your team, schedule some on-site training. All right, let me see if there's any more questions here. There should be a difference between values and functions. Values are functions with constant values and no parameters. There shouldn't be a difference between values and functions, is what Axel says. That's a good point. I think of them as values, but you're right. In a truly functional language, they are actually just functions that return a value. When it gets compiled down to IL, when F# gets compiled down to IL, as we saw, it'll actually be a property as far as a value on a module. Is there a concept of public versus private in modules? Yes. Public versus private in modules, and I can show that to you real quick. Oops, let's see. So if by default things are public, but I can make them private like so, and there's a lot of little things that are different than what you're accustomed to, and so the modifier comes immediately before the symbol in F#. Last one, just too curious to know this one. Is the type dynamic to compile time or to run time? The types are, again, F# is a strongly typed at compile time. And even for the type providers, that's true. Q, have we lost contacts as we had interfaces? Oh, have we lost contracts? Sorry, I misread that. Contracts as we have had interfaces. You feel free to give me some more clarification on that. You can do interfaces in F#, so I'm not sure if that's what you're asking. Yes, interfaces is completely implementable in F#. Nice trick with the tiny URLs in order. Yes, easy to remember. Yes, so please go through tinyurl.com/F# intro 1, 2, 3, 4, 5. Thanks a lot for your time, Walla. You're very welcome. Okay, any more questions before we bring this to a close? Okay, You're very welcome. Thank you, everyone, and thank you for the great interaction. And we'll look forward to seeing you at a future development or webinar. Got another question. Is there a list of operators? Yes, there is a list of operators. There's actually a extensive list. I didn't have it in my presentation, but yeah. The exclamation mark is not. That's the first thing that you're going to run into. Let's see. Ampersand is a lot like, it can be used like computes the address of immutable value. So it's almost like the old reference, getting the reference to a type that you would use in C or C++. Yeah, so lots of operators there. And then there appears to have been some reference to Texas, University of Texas in the comments. I'm just going to ignore that since I'm from Texas A&M. Thanks, Fred. All right, that's it. We're going to close it off. Thank you all so much.